Hi everyone. Today we're going to talk a little bit about the sun. The sun is the star that's in the center of our solar system. Now, most of you already know that, but every year I have a few students who aren't quite sure that the sun is a star. Of course, it is located at the center of our solar system, and the sun is the only star in our solar system. When we talked about galaxies uh, the day before yesterday and yesterday, we mentioned that galaxies are collections of stars, and so they contain many, many stars. But this is an actual photo of our sun taken by a space telescope, and it is the only one. This is the main source of energy for our solar system. Now, when we call the sun a star, I often have students say to me, but why does it look so much different? It looks much bigger in the sky, of course, and it's also much, much brighter. We get a lot more heat from it. And the reason for that's really simple. It's really just because our sun is much, much closer to us than the other stars. Our sun is 93 million miles away, but that is very close compared to the other stars that are light years away and sometimes millions of light years away. So when you look up and you see the stars at night, you're just looking at a sun, if you will, that is much, much further away from you. And in fact, many of those stars might be much larger and much brighter and produce much more energy than our sun, but similar to being near a campfire and standing closer or further away, we just don't feel the effects of the energy that they're creating. So I believe that I have made this point that our sun is simply a star and one of many in the Milky Way. The reason I wanted to go back to this image is because this our sun at this scale. So if we were to look at the entire Milky Way like this, would be completely invisible. It would not even be a pinpoint of light. So when we see some of these pinpoints of light here in this image, really we would be looking at something like star clusters, meaning clusters or groups of thousands or even millions of stars that are very close together. Our sun just wouldn't be able to be seen if we were to look at the Milky Way from above like this. So when we talk about our sun's composition, we're talking about what is the sun made from. And our sun's made from mostly two elements. It's made from the element hydrogen and the element helium. Now on Earth, both of those elements are in the gas state of matter. So in other words, solids, liquids, or gases. But on the sun, because it's under such extreme pressure and the temperature is so high, it's actually this hydrogen and helium are in a fourth state of matter called plasma. And so we'll talk a little bit more about plasma when we talk about states of matter later. But for now, just know that it's truly not the biggest part of the sun is truly not made of gas. It's really made of plasma. Of course, it does have an atmosphere like Earth does, and this atmosphere is considerably different. So we certainly know that our sun produces energy, heat, light, all kinds of energy. But I've had students in the past think that the sun was somehow on fire or that it was burning. But the reality is that our sun actually uses a process called nuclear fusion. And so thermonuclear fusion is where the sun is able to take some of those hydrogen atoms, some of those particles of hydrogen, and put two of them together. And when you put two of those hydrogen atoms together, you end up creating quite a bit of energy. And so that's kind of the power cell for the entire sun. I want to make sure you understand that our sun is not. It looks very peaceful when we sort of see it in the sky, um, although we can't stare at it because it's so bright without damaging our eyes. The thing that I would want you to know is the surface of the sun and even its interior are very violent. They are literally the surface is literally boiling. It's seething and sputtering and spewing materials out into the solar system and out into the space that surrounds it. And you know, if we look down at this bottom image in the bottom left in particular, I want you to notice that the sun down, or excuse me, the Earth is there shown to scale. So that's this little dot right here is meant to show you how big this loop of plasma is. And you could see that we could fit the entire Earth through that big loop that just comes off the sun. Um, so our sun is definitely by far the largest thing in our solar system, also the most massive. So this is a good picture that helps us understand how our sun compares to the planets. So of course, our sun is shown here, and then here we have some of those larger planets that are in the outer solar system. You know, we have Jupiter and Saturn. Our two largest planets. Down over here, this planet that we can barely even see, that would be the planet Euron. That's Earth. But when we look at stars versus planets, planets are much, much smaller. And our sun is by no means an abnormally large star. As a matter of fact, I've heard it described anywhere from average to on the small side. And so, that is just a big difference between planets and stars is size. So if we were to look at our sun and compare it to some of the other stars that when you go outside at night, you're looking at, we would find that our sun is much smaller than some of those stars. So right here, this little bitty dot that you can't even barely see um, above where I'm pointing right now, that would represent the size of our sun. If our sun were that size, then this would be here. These are the names of some of the stars that you can see at night. This shows you how big some of those other stars are compared to our sun. So if you look at a star called Betelgeuse, Betelgeuse is a reddish star that you can often see in the sky at night. If you compare the size of Betelgeuse to the size of our sun, it's almost incomparable. Our sun looks like Earth compared to the sun. So remember, our sun is just really an average sized star. There are stars that are much, much larger. So, uh, so I want to show you a quick video that is a comparison the size of some of the other objects that you may have heard of or that are in our solar system and in our galaxy. And so we're going to start out with some rather small objects, and they're going to work their way up to bigger objects. So we start with Earth's moon. We can see that it's relatively small. There's one of our planets, Mercury, our smallest planet. Mars, you can see is slightly larger. So Venus and Earth are relatively the same size. Those are two planets in the solar system, sister planets. Now we're looking at some of those outer planets. Here we have Neptune. See the huge size jump there. And then Saturn, even bigger. We're still looking at planets. And Jupiter. And now our sun comes into view, completely dwarfing those planets around it. Keep an eye on our sun on that bottom left corner there. You can still see our sun is this orange dot right here. It was Aldebaran. So this would give you some sort of idea. So now our sun has become completely invisible at scale. These stars are really enormous. They're much, much, much bigger than our sun. They're much, much different.